I request all the students to join as early as possible. Some of the students, I don't know why they have been removed. There may be some technical issue. If something like happens, you rejoin again, I will admit. So I'm going to share the spatial filtering PPT. I think already I have shared it. Can you see the PPT, dear students?
Yes, sir.
The spatial filtering. So these are the things what we have to discuss today. So we are going to looking towards the neighborhood of the operations. Neighborhood means already I have explained neighboring pixels of a pixel under consideration. Then how to apply the spatial filtering. What is smoothing operations? What happens at the edges? Next, correlation and convolution. Already we have discussed about that. Then sharpening of the filters, combining filters, filtering techniques. So these some of the brief concepts we are going to discuss. The neighborhood operations. Okay, so what is a neighborhood? Means the surrounding pixels of a pixel under consideration will be treated as the neighborhood. Okay, so the neighborhood operations simply operate on a larger neighborhood of pixels than point operation, and of course, neighborhoods are the mostly a rectangle around a central pixel. If you consider this here, the mouse pointer, this may be a center pixel. Then the rectangle region, okay, the pixels which are covering in the surrounding of the center pixel will be treated as the neighborhood of the pixel. So any size rectangle, any shape filter can be possible. Suppose it may be size 3x3 filter what we have applied. You can either go for 5x5 filters, 7x7 filters also you can use. So it depends on the type of filters what you can use. Okay. So suppose this may be an image. This may be an image, f of x comma y. Okay. So this may be the origin, means 0, 0. This is x coordinate and y coordinate. So this is the pixel under consideration, and these are the neighborhood pixels. Next, some of the neighborhood operations may be performed with respect to the following aspects. Like we have min of the value, we have max of the value, and as well as the median of the value. So these are the different type of the filtering mechanisms with respect to the values what we are going to consider in the filter. Okay, so min means surrounding pixels among them. We have to take the minimum. So set the pixel value to the minimum in the neighborhood. Means if you are going to apply, if you consider this image, and among these values, that is 3 plus 3, 6 plus 2, 8. So among them, which one is a smaller value? That value will be copied to all the other regions. Okay? So that is called as min. Similarly, max means identify the largest maximum value of the surrounding pixels and replace all the values with the maximum value, called as max filter. Similarly, we have a median filter. So what is this median filter? It is nothing but the median value of the set of numbers. Means so we have to find out the midpoint value here. Median means midpoint value. For example, we have a pixel values like 1, 7, 15, 18, and 24. The midpoint value is 15. The values. So this is the original image. So how it is enhanced, I will explain. Pixel E. If you consider this E is a pixel under consideration. Okay, E is a pixel under consideration. Now I am going to take a 3 cross 3 neighborhood of this pixel. So there are this is a 3 cross 3 mask. So this 3 cross 3 mask will be applied on the surrounding pixels of the pixel under consideration. That is next. If you take this, if you elaborate this, okay. So these are the original image pixels. So I'm just elaborating it. I'm just magnifying this. Okay. So these are the pixels. E is the pixel under consideration, that is the center pixel, and A, B, C, D, F, G, H, I are the neighboring pixels. Neighborhood. Sorry. Now I'm going to apply a 3 cross 3 mask, a 3 cross 3 filter. I have applied on this region. Okay, I have applied a 3 cross 3 filter now. So what happens now? The values of the filter will be multiplied with the values of the pixel values. That is, A will be multiplied with the value of the mask. See, this is a R, S, T, U, W, X, Y, Z are the mask values. So E and V are the center. E is the center of the pixel under consideration, and V is the center of the filter. Okay. So when you apply this, so a mask will be applied on this region. So multiplication will be done. First, the center element E will be multiplied with the V. So E star V, E star V plus A star R plus B star S. Like this, the process will go on. See here. So processed enhanced image is called as processed image. So E processed is equals to V star E. So this is E, this is V. So V star E plus A into R. So R into V. Then we have S, that is the filter, and multiplied with the image pixel value, that is V. So S dot R S star V plus T into C, so on to Z into I. So this is how the mask operations can be carried out on a given image f of x comma. So the above process or the above procedure is repeated for every pixel. So I have considered only this E here. So this E may be this pixel, this pixel, this pixel, this pixel, so on. So from right from the origin up to the higher value, the peak of the image or the end of the image, we have to continue this. Okay. So this is called as process can be repeated. Okay. So this is much more enhanced or representation of how a mask can be applied. A filter can be applied on a given input image. So we have an image here. So this is the image origin. This is the image f of x, right? X coordinate and y coordinate. So this is a mask. This is a mask. Mask can be represented. I have explained this in the previous class. Weights with a given weights w of -1, 1. So center value is always w of 1, 1. So one value previous means -1. One value plus means +1. Or if there is no x or y coordinate value, it becomes 0. So this is the coordinates, weighted coordinates of the filter, and this is the image segment, that is f of x minus f of x comma y. If you go towards left side, so you are going to have the y value will be reduced. If you go upwards, okay, upwards, then x value will be reduced. So this is how a given image, that is pixels of the image section, and these are the mask coefficients during coordinate arrangements. Okay, during coordinate arrangement. So filtering can be given by using the above equation. So this equation will give the filtering operation, that is g of x comma y. So g of x comma y represents the enhanced image or processed or output image, which is nothing but summation of s is equals to -a to +a, and t is equals to -2 minus b to +b. So where s and t are the spatial coordinates. S and t are the spatial coordinates, which starts from -a and +a and -b to b. ಎಲ್ಲ ಲೇಟಾಗಿ ಜಾಯಿನ್ ಆಗ್ತಾ ಇದ್ದೀರಾ, ಮತ್ತು ಅಡ್ಮಿಟ್ ಆಗ್ತಾ ಇಲ್ಲ. So okay. So now this W of S comma T means the coefficient, filter coefficient. So f of x plus s comma y plus t is nothing but the spatial coordinates values will be added to the coordinates of, that is x means rows, y means columns of the image input image of x comma y. So filtering can be given in the equation form as shown above. Notations are based on the image shown in the left. So this is the image. Now the simplest spatial filtering operations we can perform is a smoothing operation. Now image ಅನ್ನು ತಗೊಂಡ್ಬಿಟ್ಟು ಅದನ್ನ smoothing ಸ್ಮೂತ್ ಮಾಡೋದು ಹೇಗೆ ಅಂತ So that is called one of the popular technique called the smoothing of the filter operation. It is smoothing spatial filters. So how to smooth? And the image now, the quality of the picturization, visualization now smooth ಮಾಡ್ತೀವಿ ಯಾಕೆ ಅಂತಂದ್ರೆ using average filters. Average filters ಬಗ್ಗೆ ನಾನು brief ಆಗಿ ಹೇಳ್ತೀನಿ ನಿಮಗೆ. So simply average of the pixels in a neighborhood around the center value. ಪ್ರತಿಯೊಂದು values ಅನ್ನು add ಮಾಡಿ. So this is 1. If you keep on adding, you will get 9. So this value, entire total value is 9. So if you divide this one, each and every value by 9, you can get the average of the value at each position. Okay. So this is going to smooth the entire image. Okay. So average of the value will be taken, especially useful for removing noise. Okay. This is one of the noise removal technique. This is average filter. And also it is useful for highlighting gross of the detecting. Gross means average. Average filters. Okay. So how it will work? See here, this is the image. So origin, this is the origin, this is y coordinate, this is x coordinate, and f of x comma y. So this is the input image. Assume this is a pixel under consideration. That is 106. This is 106. Next, these are the surrounding pixels. Neighborhood pixels are 106. So that is 3 cross 3 neighboring pixels. 104, 100, 108, 98, 85, 90, 95, and 99 are the surrounding neighborhood pixels of pixel under consideration 106. Now, these are the original pixels which are being enhanced, magnified over here. So this is magnified pixel area. Now we are going to apply a filter, that is a 3 cross 3 smoothing filter will be applied. So as already I have given the information, it is nothing but the total count of the values divided by the total value, that is 9. So that is 1 by 9, 1 by 9, 1 by 9 will be multiplied with all the values of the corresponding pixel area. Okay, what we have considered like this. So this is the pixel, image pixels. And this 1 by 9 is an average filter. Remember, it's average filter. So these two values will be multiplied in order to get a smooth image. So here, the value E, the center value E will be evaluated like this. E is equals to first value, that is 1 by 9 into 106. This center value will be evaluated first. 1 by 9 into 106. See, 1 by 9 into 106 plus next 1 by 9 into 104, 1 by 9 into 104 plus 1 by 9 into 100, 1 by 9 into 108. The process will goes on. So when if you have calculator, you can do that. Okay. So ultimate value we are going to get is 98.33333. So this is the, see here we have the values like 104, 100, 108. So this is the average of all this. Okay. This is the average of 104, 100, 108, 99, 106, 98, 95, 90, 95. This average value. This average value will be replaced in all the positions. So it becomes a blurred image. So now the same process is repeated for each and every location. Like the 0, 0, this is 0, 0, this is 0, 1, 0, 2, like this. Okay. So all the locations. So this is the outcome of the smoothing of the images. So you can see the image over. This is the original image. This is the original image. The image at the top of the left is the original image of the size 500 by 500. So this is the area 500 by 500, that is 500 rows and 500 columns. Next, we have subsequent images shown in the image after filtering. The averaging after increases the size and the nine material. Next time material 3 cross 3 filter na apply ಮಾಡಿದ್ದೀವಿ. So this G, this is first image, this is second image. So this is 3 cross 3 image, and next is 5. 5 ಅಂತಂದ್ರೆ 5 cross 5 filter na apply ಮಾಡಿದ್ದೀವಿ. Next to 9 ಅಂತಂದ್ರೆ 9 cross 9 filter na ಇಲ್ಲಿ ಅದರ ಮೇಲೆ apply ಮಾಡಿದ್ದೀವಿ. Next 35. Okay, this is a 35 cross 35. So this is 3 cross 3. This is 5 cross 5, 9 cross 9, 15 cross 15, and this is 35 cross 35 filter. So almost image is totally blurred. Okay, the details are going to disappear over here. Okay, so that is the thing. All the regions will be smoothed. So this is called smoothing or smoothing of the spatial filter. So similar to just like our average filter, we have like weighted filters, weighted smoothing filters in particular. We want to know all the values present. Instead of counting, we are going to add them, like 1 plus 2 3, 2 plus 1 4, 4 plus 2 6, 6 plus 4 10, 10 plus 2 12, 13, 15, 16. So the total summation value will be divided by each and every value of the pixel. So this is so called as weighted average filter. Weighted averaging filter. So more effective smoothing filters can be generated by allowing the different pixels in the neighborhood, different weights in the averaging function. That is, pixels which are closer to the center pixel are more important, and the pixels which are referred to as weighted averaging. This is the if you want to, if a telescope is going to capture a celestial object or a galaxies of the universe, then we have to identify so there are so many stars here, dots here. So these dots have to be eliminated. These dots ಎಲ್ಲ ಹೋಗಬೇಕು. ನಮಗೆ ಈ ಬ್ರೈಟರ್ ರೀಜನ್ಸ್ ಮಾತ್ರ ರಿಟೈನ್ ಆಗಿ ಎಲ್ಲ ಡಾಟ್ಸ್ ಹೋಗಬೇಕು ಅಂದಾಗ, so this is the threshold image ಅಂತ ಕರಿತೀವಿ. Thresholded means the highest brighted area will be made 1 and it will be considered as one connected component. So by smoothing the original image, we are going to get a lot of finer details. Finer means dots. The small dots or stars, what you can say, they will be eliminated. And admit ಕೊಡ್ತಾ ಇದೀನಿ, ಕೆಲವರದು ಯಾಕೆ ಅಡ್ಮಿಟ್ ಆಗ್ತಾ ಇಲ್ಲ ನೋಡಿ, ಟೆಕ್ನಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ ಇರೋಂಗಿದೆ. Okay, so this is that is, by smoothing the original image, we get rid of lot of the finer details, which leaves only the gross features for thresholding. So this is the another type of image, that is median filter. So ನೋಡಿ, ಇಲ್ಲಿ original image ಇದೆ, is the circuit board. So image after average filter, ಇಲ್ಲಿ ನಾವು average filter ಮಾಡಿದೀವಿ, ಇಲ್ಲಿ image after median filter ಮಾಡಿದೀವಿ. So in median filter, we are going to get more and more details. Finer details is available because the salt and pepper noise will be removed in case of median filter. So median filters are filtering is one of used to remove noise from the images. Once again, so median filter works better than averaging filters. Averaging filters, median filter sometimes it works better. So this is a very good application of median filter. So next, spatial smoothing may be viewed as a process of estimating the value of a pixel from its neighbors. So basically, the logic behind the spatial filtering is the values with respect to the neighboring pixels will be evaluated. And what is the value that best approximates the intensity of the given pixel intensities of the neighbors? Means we have to identify the best approximate value of the pixel under consideration with respect to its neighboring pixels. And that is so called as the best establishing criterion of the quality. So that can be done by using standard measures. It is the standard criteria for some of the square difference. So this I will take in my next class. Okay. So I'm going to stop here. So if you have any queries, you can ask. Okay. So I request all of you to give your attendance. And one more thing, I hope the class to so much. I request all of you to give attendance. If anybody has not given attendance, give your attendance.